Okay, so today we're going to talk about some unions of some multiple events, and in particular, we're going to take a look at using Venn diagrams to answer some questions. So we have this problem here, and really we have three events occurring. Okay, we have some students that are involved in indoor track, we have some students that are involved in outdoor track, and we have some students that are involved in cross country. And more than anything, you need to understand that this is very much a logic problem. And as you read through this carefully, pay attention to the wording, okay? For example, if I jump down to the bottom one, it says 44% participate in outdoor track. Well, that outdoor track could be students in outdoor only. It could be students in indoor and outdoor. It could be students in outdoor and cross country. It could be students in all three. So that 44% is combining a lot of groups. There are 44% of students that participate in outdoor track in some way, shape, or form. Okay. So what I do notice is that there is an event, there is a piece of my population that participates in all three. So what I'm going to do is I'm going to draw a Venn diagram. So my Venn diagram includes a rectangle that is my universe, that is everyone, and then three circles. One, circle two, and circle three. I'll let circle one be outdoor track, circle two be indoor track, and circle three be cross country. Okay, and now what I'm going to do is try to fill in the sections of that picture. And if I look at it, for example, if I go back to outdoor track, 44% participate in outdoor track. That tells me this whole O circle is 44. That would be really silly for me to write a 44 right there because that entire O circle is cut up into one, two, three, four pieces. The best way to handle this is to go inside out. So right here, this innermost section, the combination of all three, the students that participate in indoor, outdoor, and cross country. If I go back up here, well, that's 12%. So I could put that 12% right there. Okay. And now I've got these sections. Well, who's this? This section right here are these students that participate in indoor track and cross country, but not outdoor track. Okay. If I go up here, I know 14% participate in indoor and cross country. 14% participate in indoor and cross country. Indoor and cross country is the whole thing. This whole thing is 14%, but this is already 12. So this right here has to be the additional 2%. Remember, indoor and cross country was 14%. So this whole thing is 14%. Okay, going back up here. Indoor and outdoor is 28%. Indoor and outdoor is right here. Indoor and outdoor, 28%. I've already got 12, so this has got my additional 16. Okay, now if I look carefully, I see the outdoor circle is almost filled up. Sorry, the indoor circle is almost filled up. The indoor circle is almost filled up. Well, if I look at the indoor circle, indoor tracks is 36%. Well, I have 12 and 2 is 14, plus 16 makes 30. The whole circle is 36. So this is 6% there. Okay. Go back up here. 5% participate in only cross country. Only cross country is right here, 5%. Okay. Back, 28% participate in cross country. My entire cross country circle has got to be 28%. This whole circle is 28. 5, 7, 19. So this has got to be 0.09 for 28%. And then last but not least, outdoor track is supposed to be 44%. 9 and 12 is 21. Plus 16 is 37. Plus 0.07. Okay. So what percent of the senior class does not participate in any of the running sports? That's interesting. Indoor, outdoor, cross country. How much is out here? Oh, I have 5, 7, 19, 28, 44, 51, 57%. Let's count that again. 5, 7, 19, 28, 44, 51, 57% inside my circles. So that leaves a 43% outside. So what percent do not participate in any of the running sports? 43%. What percent of senior class participate in only outdoor track? Only outdoor track? 7%. Okay? So this is me using Venn diagrams to try to answer some union questions. Okay? Could look at another example here. Okay? Drawing a card from a well-shuffled deck. A, the card is a king. B, the card is a diamond. C, the card is a face card, jack, queen, or king. All right. Let me draw my Venn diagram. Okay. So I have my kings. Okay. Interestingly enough, I have my diamonds. Okay. And then what's really weird is that C, the card is a face card, jack, queen, or king. That is an event that includes kings. So here's what I'm going to do. I'm going to do this. Face card. Okay? Because my face card includes all of these kings, right? My face card includes all of these kings. That's a really poor drawing. Let me draw that again. Okay? So I have my kings, and then I have my diamonds, okay? And then my kings are really a part of my face card. So I'm going to do this. So these are my face cards, okay? So this section right here is all three. There is one card that is a king, a diamond, and a face card. That is the king of diamonds. There's one card that fits right there, okay? Now, there are two other cards that are face cards and diamonds. That is the queen and jack of diamonds. So there are two cards that fit right there, okay? Now, because there are 13 of each suit, there are 10 other diamonds, okay? There are 3 other kings, okay? So there are 3 kings that are not diamonds, 1 king that is a diamond. There are 2 face cards that are diamonds that are not a king. And right now, I'm currently counting 6 of my face cards. Well, there are an additional 6 other face cards that are not kings and not diamonds. I'll prove it to you, okay? There is the Jack of Hearts. There is the Queen of Hearts. There is the Jack of Spades. There is the Queen of Spades. Okay? There is the Jack of Clubs. There is the Queen of Clubs. Okay? So every other face card is either a diamond or a king. So 6 face cards that are not counted inside there. Okay? Now currently I have 6, 9, 10, 12, 22 cards. There are really 52 in a deck, so there are 30 cards outside of my Venn diagram. Now you'll notice that this time around, instead of listing probabilities, I listed counts, right? No big deal. Okay? So the probability that the card is a king, okay? A, king. Well, king is just my K circle. So there are 4 cards that are kings. So that would be 4 out of 52 or 1/13. The probability the card is a diamond. Diamond is the D circle, 10, 11, 13, 13 out of 52, which is 1/4. The probability the card is a face card. Face card is 6, 7, 8, 9, 10, 11, 12, 12 out of 52, which reduces to, what is that, 3/13. Okay? The probability that the card is a king or a diamond. A king, 3, 4, 5, 6, teen. King or diamond includes all the K circle or all the D circle, so 16 out of 52, which is 4/13. Diamond or a face card. Diamond or a face card. This one or this one. Oh, okay. 10, 11, 12, 13, 16, 22. So that's 22 out of 52, which is 11/26. King or a face card. Oh, I think I did that one wrong. No, king or a face card. King or a face card is 3, 4, 5, 6, 12. King or a face card, 12 out of 52, which is just 3/13 again. Now, by the way, you might look and say, Mr. Russo, that's the same thing as the probability the card's a face card. The probability the card is a king or a face card is the same as the probability the card is a face card. Well, of course it is. That's because A is a subset of C. We already said that. The card being a king is counted inside the card being a face card. King is a subset of face card. King is completely inside face card. Last but certainly not least, king or a diamond or a face card. King or a diamond or a face card is just adding these all up together again. 3, 4, 5, 6, 12, 22. 22 out of 52, which again is 11/26. I'm going to go back and look at that diamond or face card again. Diamond or face card. Yeah, that is exactly the same because, again, the king is just a subset of face card. So it's no surprise that these two are equal to each other. Now, again, there are other ways to do a problem like this, but I'm just showing you some ways that those Venn diagrams can be useful. You may have found it more useful in this problem than you did this one. Okay? More than anything, guys, it's logic. Hope you like my little bat sticker. Have a good day.